Great. All right. Good morning, everyone. Thank you so much for being here. My name is Christina. I am from Sage Bionetworks, and today we're going to be talking about how to reuse data on the NF data portal. I'll be with my colleagues here, Janita and Robert, and we'll all be taking a role in this workshop. So just some logistics first. We did ask you to bring your laptops. You're welcome to kind of follow along during the presentation, and we'll have a working session that is about 30 or 40 minutes at the end, or really like halfway through the session. If you haven't already seen, there's a green and red card. If everyone just can check if you have one, we have some extras here that we'll pass out. That is just to symbolize if you need help. So red is that you want help, and green would be that you're good to go. So it just allows us to look to see who wants help while not having to raise your hand. And then the only other thing is I have my phone to check people in just to make sure we know who was here and to send any follow-up. So if you haven't checked in with me or haven't gotten your name, I'll probably try to see the last people. So with that, and then sorry, one more announcement. There is an email that was sent, and that is to link your NF data portal account with Cavatica. We have a lot of people that already did that. I also just sent the email out for people that are newly registered. It's going to walk through that in this session. So if you haven't done that step, don't worry, you can do it either during the session or when we get to the breakout of work session. Okay, so let's get started. So to start out, we're going to do an introduction. Oh, I have it here. Introduction, talk about locating data on the NF data portal and interacting with data from the NF data portal to CBio portal. And then there'll be a demonstration using R and Cavatica, and then the work session where we'll have our team assist you with data access, and then a closing survey, which we really do appreciate if you stay that 5 minutes to take that survey. Okay, so let's get started with who makes the NF data portal and what is it. So we're from Sage Bionetworks. We're graciously funded by Gilbert Family Foundation, Children's Tumor Foundation, and NTAP. And to give you a sense of the amount of data, there's 29,000 or the amount of use of the portal. There's 29,000 file downloads and 409 unique users in the last 12 months. There are 248 studies, and it's constantly growing. And some of the types of data include drug screening, imaging, genomic variants, gene expression, and more. So the website is called nf.synapse.org, and the portal was created a few years ago in order to accelerate NF research by providing a centralized and accessible platform for data sharing and collaboration. And our mission is to enhance the understanding of NF, facilitate the discovery of new treatments, and improve patient outcomes. So to get started, visit nf.synapse.org. You'll have to create an account, and you can explore the data sets and utilize analytical tools and participate in the community. So, and many of you here we already know are familiar with the NF data portal, but to get just a view of it, so this is the front page of the portal. There is at the top left, a browse tools, and this is a repository of animal models, cell lines, antibodies, genetic reagents, and biobanks, and this has been curated. We'll actually be talking about this a little bit more in session 2. If you go to the Explore tab, there are the initiatives, studies, data sets, files, so this is the first step to how you would navigate to try to find data. And then we also have this help section, which is documentation. So what I'm going to talk about is just what each of these components, just the layout of the portal is. So initiatives, these are initiatives that are set out by the funding agencies, and a lot of them focus on a specific type of research. So this might be a good way to find a project that's related to a topic of interest. Then just briefly going over studies. So when you click studies, there'll be a few ways to filter your projects. If you're looking for data that is available, you would go to data status, check available. You could also explore what's currently going on. So as soon as a project gets initiated from one of these funders, it's visible on our portal. So if you click data pending, those would be probably the newer studies that have just gotten funded. And then data that's under embargo means that data is uploaded, but it might not be published yet. So that's a situation where you might be able to just contact the investigator and get some early access to the data. There's also ways to filter by manifestation, the disease focus, and data type. So this video is going to go over selecting data sets. So just what you're seeing, so we're on the NF data portal right now. If you go to Explore, you'll click data sets. So data sets are groups of files together that make up a data set. And one of the steps that we do on our end, which Janita's going to talk a little bit more, is we're reprocessing data sets. So if you click this NF-OSI checkbox, those are data sets that we've been reprocessing, and this is kind of like a good way to filter out what large data sets, they're going to be well annotated, and you're able to download them all at the same time. So this is showing once you click a data set, you can see show more is going to show the details. And if you see on the right, there's this download option, so adding all files to the download cart. So you don't need to individually download files, but you download the entire data set together. And you can view your download cart. So this is just highlighting there's two options to do this. There's a web download, and then you can also programmatically download the files. Okay, so one thing I want to mention, and we get this, we'll go over files, and then I'll say one more thing about this type of, so files is a way of just querying, all of the data that's on the portal. This might be a really good way to narrow down. If you are thinking, okay, I want to find this data set, I want to find this file type, you can navigate through files, and you might be able to narrow down a group of files that come from the study. I would recommend you then go to the study, you learn more about the study rather than the individual file level. That's a challenge to understand what's going on. But files, to me, it's a great way to just narrow down how many data, files are available. And so next, I want to just highlight where to find metadata. So if you click that download button and then you click export table, there's going to be a lot of metadata that's associated with those files, and you can download that as a CSV, and you can also click this show/hide columns in the right side, and it will list out all of the metadata that's been submitted. So how do you know whether you have access to the data? So we try to make the data, as accessible as possible. There still might be restrictions depending on the sensitivity of the data. So if you see this green unlock button, you have access. If you see the golden or yellow lock, that means that there is an access restriction, or the data is not shared, but there's likely just another step that you have to do. So I'm just going to show an example of how it will look. So here, clicking that yellow unlock button, adding all of the files to the download cart. Then you view your download cart, and there is this access actions required, and so this is completing that access restriction for all of the files at once. And for example, the or the Johns Hopkins NF1 biospecimen repository, for this, you have to write just like your intended, use of the data. If you ever come across a situation where there are restrictions, we really, reach out to us and we can help you kind of like understand how to know if you have access to that data. Okay, so I'm going to pass it to Janita next.
Thanks, Christina. I'm Janita Banerjee. I'm a principal scientist at Sage Bionetworks, and really great to be here with you today. So I'll talk about a few things that we are doing with the data that you just saw that is available to you on the NF data portal. And one of the questions that we started with is to kind of understand how people are using or would like to use the data that is available on the NF data portal. So we anecdotally talked to a few of you who have been in the NF research community, and we found some use cases that people were interested in. So as an NF researcher, people were interested in comparing their own data that may be on the data portal, but with other studies that could be in the NF data portal or somewhere else, for example, CBio portal. We found PIs or postdocs trying to make quick visualizations that they could, from data that was shared by their colleagues, kind of in support of their hypothesis or a recent grant proposal. We saw that bench scientists who are very much into their experiments and may not have enough time to computationally analyze new data, they would like to have the ability to quickly click and point or point and click and explore some of the data that was available. And then we also found clinician scientists who were very interested in exploring the data on the CBio portal, which they were very familiar with. So to kind of cater to some of these use cases that NF researchers were facing on a daily basis, we started doing something that would enable these needs. So we started an initiative where we were helping data from the NF data portal to be available elsewhere, where you could get easy exploration or easy point-and-click access to understand what the data was about. And one of these platforms was CBio portal, which came up in many of our conversations. So with NTAP's support, we actually did something that for the initial parts of the initiative was to find some eligible data sets, mainly genomics data sets, because CBio portal is very genomics heavy. So eligible data sets that are coming into the NF data portal. Sage Bionetworks actually helped process these data using standardized pipelines, formatted the data according to the CBio portal requirements, and after express approval from the study leads, we were able to forward these data on the CBio portal so that you could now use the visualizations of CBio portal to explore some of these data. So to see how you might know which data on the NF data portal are available on CBio portal and how to kind of work with them, here is a short video, and I'll walk you through it. So again, going into the NF data portal, you might want to explore the data sets. So when you go to the data sets, you might see NF-OSI as the creator. So those are the ones that we have processed in-house. You might filter a specific study that you're interested in. So here we are selecting the Johns Hopkins biospecimen repository, and then there is the visualize data on. And this is where you will find where data has been visualized or can be visualized. And once you click the CBio portal, you can find all the data sets that are on CBio portal. So if you go on the data card itself and click on the CBio portal link that is provided right on the data card, it will get you to the study, to the same study on the CBio portal. So you can now take advantage of all the visualizations that CBio portal readily provides to explore the study that you already selected. And then you could also try other things like compare your study with other studies that are on CBio portal. So let's say I'm interested in peripheral nerve sheath studies, and here is a whole list of different studies, including the Johns Hopkins specimen repository, and I could click or select all of the studies together and then query by gene, because I want to know what my favorite gene is doing in any of these studies. So I could add in some optional favorite genes of mine that I want to visualize among all of these studies. So I add in the names here and submit the query. So CBio portal has a lot of built-in visualizations. Here is a very popular one, which is called an oncoprint, where you can visualize variants, genomic variants. And this is where you find all the samples from the various studies and all of the variants and mutations that are in those favorite genes of mine right there. You can download the plot itself as a PNG and also visualize other things like lollipop plots like that, where you can visualize where each of the variants are in the gene positionally. So, and again, this is again something, a visualization that you can download as a PNG and put it in your grant proposal or anywhere else if you want. Let's say that I want to also understand the clinical data that is associated with these studies. So we could go back, select the same studies and explore the study itself. CBio portal provides a lot of information of like survival plots, structural variants, any of these kind of data that each of these studies have provided, and you can explore these, and any of these visualizations can also be downloaded as plots and PNG files. So you could also download the clinical data from all of the studies together. You could also share this virtual study that you have now made using your own favorite data set from the NF data portal and the data set that is available on CBio portal. All right, so with that, I will hand it over to Robert for the next set of information.
Hi, everyone. I'm Robert Alloway. We've possibly met before, but if we hadn't, we'd love to chat later. I'm a bit of an interloper here because I'm actually filling in for one of my colleagues, Anwet, who wasn't able to make the conference. So we'll be watching a few videos of her exploring data programmatically. And so the question we have here is, what if I want to access and work with raw data files instead of going to CBio portal and kind of having these pre-baked analyses done? And so there are a couple of different use cases we encountered when we talked to the NF community, the NF researcher community here. So in the case of an NF researcher, they might have generated a bunch of malignant peripheral nerve sheath tumor sequencing data, and now they want to take all of the other MPNST data that's on the NF data portal and compare it alongside their own data. And so you could do that through CBio portal at a surface level, but you might have a question like, what alternative splicing events happen in this RNA-seq data, or which is not something that you can do with CBio portal. And so you'd have to access the raw data and run your own bioinformatics pipelines to do that. In the case of a computational scientist, generally, speaking from personal experience, the preference is to start with the raw data and run the tools that you're either most familiar with or comfortable using to analyze. Or maybe in the case of computational scientists, they might be developing new algorithms as well. And, oh, that's backwards. There we go. And so, yeah, like I said, our colleague Anwet has prepared some videos doing this type of analysis programmatically, either through an R notebook or through Cavatica. it will probably go pretty quickly, but not to worry. We have, during the workshop portion of the session or the free time portion of the session, we have some exercises that you can run through at your own pace. And so this is really just meant to be an intro to doing this type of analysis.
All right, so here's that CTF study that we're going to reuse in terms of data analysis. I'll scroll down a bit, and you can see that there are tabs and something like a file browser, just like the global file browser, with kind of similar facets. Here, I know that I want some salmon quantitation files, so I can select that. And in a lot of cases, it's easier entry point than the main file browser. And I can send all these results to Chromatica. When you do that, you can go through this flow. You see that there's 2 requirements. You must be logged in, and you must connect your Chromatica account to Synapse. So let's log in. Here's the Chromatica website. Entering my information. Presented with Chromatica dashboard. So let's go back and attempt to send our results. And I know that this won't work, but here's what it'll look like when you do so. Oh no, it didn't work. So this is where the second requirement comes in. And what you need to do is go to account settings, click on dataset access, and then there's this somewhat long list of things. We need to scroll down, and what exactly are we looking for? So scroll all the way down to Synapse portal. Here you can click connect. Allow. And you just want to check. Okay, so there's an expiration as well for the connection, but we should be good now. So now we can successfully send our results to Chromatica. So make sure it's the project that you want. And it feels pretty much instant. It's, a few hundred megabytes of data. You can then see the files all there. And so there's some metadata on the files that you can view. So I'm going to go ahead and try to surface some columns of metadata that I know exists. So some are kind of selected by default, but, what is going to be relevant for us are things like individual ID, diagnosis, tumor type, genotypes, etc. So what's most relevant should appear currently. There might be a few things that don't get transferred automatically, but this is what we need. In fact, we can go back and do a comparison against Synapse. So normally you would click on a file, go to the file page, and to see annotations, click on that annotation tag on the top right. you can see what's actually on the file. So there are a couple of things that it seems weren't imported to Chromatica, but that's fine. So just one more thing. You can see that there's annotations here in this CSV, which is a lot simpler to use. And this is, in fact, what we'll be using for the analysis. So there's the file, metadata, and then there's some basic clinical data that we'll use with our analysis. All right, well, it's time. I hope everyone is excited. Let's go to our data studio.
Cool. And so now that we've imported our data from the data portal to Chromatica, we'll run through a quick example of an analysis of the data in CBioPortal using this CTF cutaneous neurofibroma data as an example.
All right, so we are loading into Data Studio, and our studio is starting up. Okay, so you should see a very typical RStudio session with just tumor decon or markdown file already pulled up. And because it is a collaborative cloud environment, you might see other files that your colleagues are working on at the same time. So you see this DSeq2 R markdown file on the left. That's something that my colleague is working on in the same project. To help explain an R markdown file a little more, it's something that mixes code and narrative to help others better understand your analysis. And what's also nice is that things are more reproducible. So in Chromatica, popular packages here are most of the time pre-installed and you won't need to have to worry about it. But when you do need to, it is easy to pull in your own dependencies to install those additional packages. The main one that we'll be working with is the immune deconf, that first one that we've already set up for this analysis. Here are the packages that we'll use, and so we load these. So there's an introductory section describing our analysis idea. So this is a tumor deconvolution where we're trying to look at some immune cell distributions in this cutaneous neurofibroma environment. So I have some references as well, which we're not going to go into. Our first order of events is locating files and clinical data. So we already have these files, as you saw earlier. They were imported through the UI flow. So normally you'd have to use the Synapser package if you're working locally, but we don't have to worry about that. So we could easily read these ins. We just know what they are. And I'll go ahead and do that. Yeah, they look as expected. What we saw earlier, in fact. So what we have is transcript level mRNA expression from bulk RNA-seq. So that's what these Talman quantitation files are. And we need gene level expression as our input into the analysis. And it would be much more helpful to show you what these files look like. So here I'm just going to show an example file with some description of what you can expect as the columns. So here you can see really we have the transcript IDs, length, effective length, and TPM is our unit of quantification, transcripts per million. And we need to map these into gene names, so HECO-gene names. So we'll do that with just a bit of lookup and data wrangling. So I'm using a resource from the package ecosystem to create our mapping file. And so you can see transcript ID to gene name. We're going to use TX import to conveniently read all these files into a single data object that we need as input. So once I have that mapping reference, I can just go ahead and run this one line. And I'll create a couple of different matrices. The abundance matrix is what we need. So shown here, and it's a very standard format to have genes as rows and patient samples as columns. So now we can run the analysis. So the package does include many options, and you could read more about these. We're going to go with one of the two recommended in the benchmarking paper. So these two are EPIC and QuantiSeq, recommended for general purpose deconvolution. The outputs of these are estimated absolute fractions for each immune cell type. The other methods give you more of a relative estimation. We're going to go with QuantiSeq. And this will take a few minutes to run, so I'm going to cut and skip ahead to when we get results. All right, a bit of a time skip here. We're going to see results pretty soon. All right, and this is what the output looks like. We have our different immune cell types and the fractions for each of the tumor samples. This is a little hard to parse, so what we want to do is visualize this. And so we'll create a figure using a couple of standard plotting libraries in R, so ggplot, and some helper data wrangling libraries. So first I need to sort of reformat the data a little bit to what's called long format. And I already have some plotting functions. And so we see here, this is a box plot of the distribution for each specific cell type. You can see how variable they are across these cutaneous neurofibromatosis tumors. And that's pretty basic. We can do another figure with some additional grouping. So to figure that out, let's make use of the basic clinical data that we already have on the files. We're going to subset the attributes to just the clinical fields, and then we'll confirm what we have in terms of the patient demographics. And so it looks like, again, we have the same tumor types across all the samples and the same genotypes for NF1 and NF2. So we're not going to be doing some sort of cross-disease or tumor type comparison, but we do see that there are multiple tumors per individual patient. So let's explore that a little more. Here I'm going to see how many tumors per individual and make a little plot to visualize. So looking at this, we see that there are really three groups: patients with 2 tumors, patients with 3 tumors, and patients with 4 tumor samples, which might correlate to their the actual number of tumors that they had. So we'll use this. So we'll create grouping factors data table for this with the 2, 3, and 4 tumors groups, and then run the figure generation to see what that looks like. So the main difference that you see here are that the groups are broken out to the 2, 3, and 4 tumor groups. Is kind of interesting that monocytes show kind of the biggest difference between the tumor group 2 versus 3 and 4. Here's also where I should perhaps provide more interpretation, but we're going to move on. So this is a pretty small cohort, number of samples, and we don't expect any significant differences, but we do want to show some example code where you could go a little further and try to combine these 3 groups into 2 or sort of collapse them and so get more power for some statistical testing. So we do that here. We're going to combine the groups 3 and 4 since they look the most similar, in our figure. And then we'll run the test. So here are the results. As the last part, we will show the session info with the package versions. This is pretty important, and citations to acknowledge the tools that we used for this analysis. All right, thanks everyone, and I hope you start your own exploration.
All right. And so this is all great, but you don't have to use Cavatica. Cavatica is a cloud-based platform that you have to pay for if you don't have free credits that we have for this workshop. And so you might just want to use your local machine, download some data, and explore the data locally. There are some potential advantages to using stuff on your local machine. So you if you have a powerful local machine, you might have some speed and performance increases on your local machine than in a cloud environment where the machines available to you can be restricted. You don't have to pay any extra for downloading the data. You have enhanced control over where the data lives. And you can work offline, so you don't have to be attached to the internet to do your work, which in terms of practical benefits, I think is probably the biggest. And so this is just a quick tutorial of using our Synapser R package, which is a package that works with our API to download data from the NF data portal onto your local machine.
So we showed in another session that you can easily get data with the Synapse UI, especially that nice integration that lets you send data to other platforms like Cavatica. But sometimes you don't want to use Cavatica and you just want to get data programmatically into your local machine. So this follow-up guides you through the general programmatic method of getting data to where you are. We'll walk through the recommended credentials setup in under a minute. And then we'll show you how to install the R client and how to use it. In Synapse, you'll need to access your account settings. So navigate there. And then we'll need to find something called personal access tokens, which is near the bottom. So manage personal access tokens. We're going to create a new token. I'm going to call it temp. And you generally need view and download permissions for getting data. So we'll create this token. We're going to copy it, and we're going to use this on our local machine. It's recommended that you use the personal access token to authorize whenever using a programmatic client. It's convenient to store it as an environmental variable in R, which I'll show here. I want to add it to a file called .renviron. And so I create this file and add a variable called synapse auth token and just copy and paste in that token from earlier. Okay, now we need to install Synapser, the R client. I'm copying in the instructions from the docs. I'm going to restart R just to make sure my token is reset in the session. And then I'll paste in the instructions. Just going to modify it a little bit. And not log in with username and password. We have our token set. And I'll just run this. And you can see it's starting to install the packages. It will only take a few seconds. So you do actually get the Python installation as well when you install the R client. Because the R client is built on top of the Python client. So once we've built and installed the packages, you see we are logged in. Okay, so we're going to search for another CTF dataset. And since I'm going to show you download to my laptop, I'm going to try to choose a smallish dataset. Let's see what we get. Okay, so we're going to use this CNV dataset, also from CTF. And this is what the dataset page looks like. I want to point out that you might not see all the available metadata at once. So you just kind of have to see what else is available by going to that tab there. And so to download in the UI, you can click on the download option. So you'll see an estimated time it'll take for download, and it won't be much. It's a small data set, not enough time for you to go and get a coffee. So we'll just add these files, and then we can go to the page where you can select how to download. So the easiest way through the UI is to do the zip package option here. And you'll just need to enter in a super creative name for your zip, like data.zip. And once created, that clears your download cart. Okay, so we're going to do something like Groundhog Day, where we wake up and decide to do something a little different, and that's the programmatic option. Going straight to R here, you see the instructions saying that we can download the metadata with this query you see, and then there's an instruction for using synget to loop over a list of synapse IDs for batch following files. So we're going to see what that looks like in our session. After logging in, I'm going to run a query for that metadata, just like we saw almost. And here's the query. Here's what our table looks like once we submit the query and retrieve the data results. Now we need to figure out batch download of files. So there's two ways you can do this. If you created the download list, like we saw earlier in the UI, but you didn't want to get a zip package, you can download it programmatically like this. And if you don't have a download folder, I'll create one for you. So you can see on the right. And check my files out of there. And then the second option is to do that loop with synget. So first you need to get the dataset. And using the dataset ID, you can see kind of a preview of some of the files and their versions in there. And then construct your loop to get your files one by one into a second data directory called download2. That's also created. So that's the gist of getting data from an existing data set that you find. However, there may be times when you need to create a data set. And here's a brief when and why. So the analysis-ready dataset may not already exist for some collection of files you're interested in, or you need to create a dataset in your own project to keep track with each analysis version, because as we know, often the analysis will change a number of times with different data. You can find out that some files have issues and they need to be removed, and they explained why your results looked awful, or you just need to update a couple of file versions in your data set. Or later, it's possible that you want to add more data, combine data from other projects with what you have. And that's what data sets are for. So this is how we create a data set. You just need to have a project that you can store it in. We already set up a tutorial project with no data sets yet. But after you run your dataset creation, you'll see your dataset created in the project. And from there, you should be able to download files just like you did earlier by getting the IDs for dataset items and then using your loop.
All right. And so There will be one of the exercises in the breakout session later that allows you to run through those notebooks that Anuet just ran through. But before we get to the breakout sessions, I did want to highlight a sneak peek of where we're looking forward, where we're going. So we didn't, based on when we started this project, we didn't quite have time to work it into this workshop. But we're with CTF support, working in collaboration with a company called Pluto.bio, which has a no-code analysis platform. And we're actually conducting a pilot project at the moment with low-grade glioma data. I'll provide details on that in a second. But first, let's take a quick look at what Pluto.bio is.
Introducing Pluto, a collaborative life sciences platform re-envisioning scientific research from the ground up. Pluto gives scientists the ability to manage their data, run powerful bioinformatics analysis, and create interactive, publication-quality visualizations, all from an intuitive, visually inspired, cloud-based platform. This means test your hypotheses faster. Turn every experiment into immediate insight. Go from raw data to publication-ready plots in minutes, not weeks. And compare your results to the latest published research to validate your findings and generate even more new ideas. As scientists, we believe in changing the world, one discovery at a time, taking knowledge gained and collaborating with our broader scientific teams, each new discovery building on the next, leading to impact. Since its launch in 2021, Pluto has become a trusted partner of life sciences organizations around the country, ranging from emerging biotech startups to multi-team biopharma organizations. Why? Pluto accelerates scientific discovery with a centralized, secure home for all of your data, accessible from anywhere in the world. Pluto allows you to quickly collaborate on research, invite colleagues to view your analysis and leave comments, or present your results live to get feedback from your team in real time. Teams around the world are using Pluto to accelerate their work on a wide variety of areas, from preclinical and translational science research to cell and gene therapies, drug discovery and development, even clinical research. There are thousands of scientists in the world. Together, we can make our world better. Pluto, the first step to a modern, discovery-focused team.
So our strategy with the NF data portal for the coming years is really to become a clearinghouse for NF data. If you've used the NF data portal, our focus really is data curation, organization, making sure that the data is robust and worth your time in using it. But we don't have a bunch of analysis features baked into the portal. That's not been our focus for the past several years. And so we're really excited to start collaborating with groups like Pluto and with CBioPortal to integrate data into other platforms that are more analysis focused so that we can make sure that anyone, whether they're bioinformaticians or not, can start working with the data and exploring it. And so this is a quick plug or invitation to join CTF's pilot project that integrates the NF data portal with Pluto.bio. I apologize for making the slides, the text so tiny, because it's really hard to read. But in brief, we have a need for no-code data analysis tools. We've talked with the NF community in a couple of working sessions over the past year that really highlighted this as a need. And so for this pilot, it will run for roughly 3 months, starting late June or early July. The people who ideally would participate in this are people who are interested in low-grade glioma, working with genomic data, or either have limited or advanced experience in bioinformatics. And what we're asking of the participants is to, when they're provided with a Pluto.bio account and some low-grade glioma data from the NF data portal and some onboarding training, to explore the platform, play with it for 8 weeks, poke around in the low-grade glioma data, let us know what you like, what you don't like, and we'll solicit that feedback at the end of the pilot project and figure out whether we want to move forward with them as a more kind of holistic integration where you could send any data from the NF data portal to CBioPortal, similar to what you saw with Cavatica earlier. If you're interested, in the survey at the end of the session, we have a place where you can note your interest in that, and we'll follow up with you. You can also email Irene Morgenstern at her email below. She's also in the back of the room, standing up. So yeah, I strongly encourage you to take advantage of this. I've used Pluto a couple times, taken a couple of test runs, and it's a really, really cool and easy to use platform. And so before we jump into the working session, we wanted to see if there are any questions about the material we've presented thus far. Yeah. Mm-hmm. Yeah, so our drop-in sessions, if you note there's like a little, in the registration form, there's like, what are you hoping to get out of this session? If you note that like you're interested in doing something in Python, we're happy to make sure that the right people on our side are at that session so that we can provide you with support. So I'm like more of an R person. I do a little bit of Python here and there, but we definitely have more people who are more expert in Python as well who can help you out. Yep. All right. So if that's it, I'm going to highlight some 3 options for this working session. So we've put together 3 exercises that you can pick and choose from depending on how quickly you get through the exercises and which ones resonate with you the most. So the first option is a no-code option, and this is to do a similar exercise to what Janita was presenting to explore the Johns Hopkins NF1 biospecimen repository data, but on cBioportal. And so we're hoping what you'll get out of this exercise, if you pick this one, is to understand a little bit more about what data sets are in the NF data portal, how to get from NF data on the data portal over to the associated cBioportal data, and explore some of that NF data in cBioportal. And we'll have all 3 of these options up in a moment, so you'll be able to see and compare them. The second option for this exercise, or the second exercise option, is to search the NF data portal, much like Anouette did in her video, find data of interest, and then send it to Kavatica. So if you've signed up to Kavatica and I've added you to the workspace, you should be able to explore some of that data in Kavatica, run your own analyses. We have the notebooks that Anouette presented also in those workspaces if you'd like to run through those with the data that are already there. And so we're hoping what people will get out of this exercise is to explore the data portal, find files that they care about, find data types that they care about, learn how to take data from the data portal and send it over to Kavatica, and understand how to explore the metadata for the data both on the data portal side as well as the Kavatica side, and running an example R analysis over in the Kavatica Data Studio. And then the third working session suggestion that we have, or option, is to search the NF data portal and run through an analysis like the one we saw right at the end there, where you find some data on the data portal, download it to your local computer, and do some basic analysis or visualization. And so we're hoping that you get out of this exercise, like understand how to install the Synapser R package or the Synapse Client Python package, download some data, and do a beginning analysis with it. And so these are the 3 options. We will be circulating around the room trying to help people run through these 3 options. You all should have cards on your table where one side is red, one side is green. If you'd like a colorblind friendly one, let us know, we can make that. And if you need help, just have the red side up. If you don't need help, you're all good, just have the green side up, and that will help us get around to as many people as possible without making you hold your hand up for minutes or longer. And yeah, we'll just leave it at that.